Students, today we will discuss some important questions and which are expected in different entrance exams from 4th year group, what we call it as carbon family. This is the question number 1. Which is not the property of diamond? A. It is insoluble in all the solvents is given. Yes, it is insoluble in all the solvents. Then isomer of graphite. But see, diamond is not isomer of graphite. This graphite and diamond are actually allotropes of each other. Allotropes of carbon. The purest form of carbon, we agree. Carbon is, this diamond is actually purest form of carbon. Among all the allotropes, it is one of the purest form of carbon. It is oxidized with a mixture of potassium dichromate and sulfuric acid at 200 degrees centigrade. Yes, diamond whenever reacts with acidified potassium dichromate, there is a choice of oxidation to produce carbon dioxide. Therefore, option B, it is an isomer of graphite. It is not the isomer. This is actually diamond and graphite. Both are allotropes of carbon. Therefore, question number 1, answer is B. Question number 2, diamond and graphite both are made of carbon atoms. Diamond is extremely hard, whereas graphite is soft. This is because diamond is a hard substance and graphite is what? Soft substance. Both are actually allotropes of carbon, both are made up of carbon. What is the reason behind it? Coming to option A. The chemical bond between any two carbon atoms in diamond are actually stronger is given. Between two carbon atoms, the bond is stronger. Coming to second, diamond is ionic whereas graphite is covalent. See, diamond and graphite both are actually covalent compounds only. Simply these are non-polar, these are not ionic, these are covalent compounds. Covalent, not compound actually, covalent substances. It's better to say covalent substances, not ionic substances. Each carbon atom in diamond is chemically bonded with strong bonds to 4 neighboring carbon atoms, while graphite has a layered structure. Yes, in the case of diamond, each carbon atom is linked to 4 neighboring carbon atoms, the strong covalent bonds, sigma bonds, like this. Strong sigma bonds in a tetrahedral geometry. But to talk about graphite, graphite is having actually a layered structure. Hexagonal layers are there in graphite. This is one of the layer. Another layer you take. These are actually layers of graphite. The layers are held by weak van der Waals force of attraction. The distance also very weak. Distance between the layers, and they are held by weak van der Waals force of attraction. Therefore, graphite is actually soft. Coming to option D, certain atoms in diamond are smaller in size. No, all are actually carbon atoms. How can they be smaller? All are having same size. So, diamond and graphite both are made up of carbon and carbon atoms. Diamond is hard, graphite is soft. Only the carbon atoms are linked to 4 neighboring carbon atoms with strong covalent bonds. In the graphite, graphite is actually layered structure. In between the layers, weak van der Waals force of attractions are there. Therefore, that is soft. That is the correct answer. Therefore, question number 2, C is the answer. Each carbon atom in diamond is chemically bonded with strong bonds to 4 neighboring carbon atoms. But graphite is what? Layered structure. Therefore, it is soft. So, question number 2, answer is C. Question number 3, which form of carbon is used in making boot polish, printing ink, paint and black varnish? A is bond black, B is graphite, C is gas carbon, D is lamp black. See, which of these particular allotropes of carbon is used in the preparation of a boot polish, ink, black ink, etc. Bond black, there is no such carbon actually, bond black. Coming to graphite. Graphite is not generally not used to make inks. Generally, graphite is used to act as what? A lubricant, and also it is also used in the preparation of lead pencils. Gas carbon. See, gas carbon is actually conductor. Therefore, gas carbon is generally used to make electrodes. Coming to lamp black. Lamp black, if you talk about lamp black, this particular lamp black is actually a fine powder of carbon. This is generally used in the preparation of what? Boot polish and black ink, etc. Therefore, question number 3, answer is D. Question number 4, thermodynamically most stable form of carbon is A. diamond, B. coke, charcoal and graphite. See, graphite is actually thermodynamically more stable because its free energy of formation is less than diamond. Graphite formation, the free energy of formation is less than diamond. Therefore, among this particular diamond, coke, charcoal and graphite, thermodynamically graphite is actually more stable. Therefore, question number 4, answer is D. Question number 5, carbon and silicon belong to 4th A group, that is or 14th vertical column. The maximum quantity number of carbon in commonly occurring carbon is only 4, but whereas that for silicon is 6. This is due to A. large size of silicon, B. availability of vacant d orbitals in silicon, C. more electropositive nature of silicon, D. silicon being vulnerable to attack by nucleophilic reagents. Generally, atom is actually forming coordinate number 6, atom is not forming coordinate number 6. Suppose CCl6 generally we won't find, but generally we find CCl6. CCl6 is not generally found, but SiCl6 minus 2 is there. If you talk about carbon and silicon, generally coordinate number 6, there should be hybridization sp3d2. sp3d2. If the carbon atom is not carrying vacant d orbitals, then it cannot form a compound with coordinate number 6. Therefore, CCl6 doesn't exist, SiCl6 minus 2 exists. Therefore, here carbon is not capable of forming compound with coordinate number 6, but silicon is capable of forming. Only the reason is presence of vacant d orbitals in silicon and absence of vacant d orbitals in carbon. Therefore, question number 5, answer coming to be B.